In this video, I'm going to solve this first order linear differential equation. The general format for the first order linear differential equation is this: dy over dt plus p of t y is equal to g of t. And in our case, our p of t is the coefficient of y, which is just 1 over t. And we will be using the integrating factor. As you know, to solve first order linear differential equation, we have to multiply both sides of this equation by the integrating factor. And integrating factor is defined as mu of t, that's the function of t, is equal to e to the power integral p of t, that's the coefficient of y, dt. So in this particular problem, our p of t is 1 over t, and then we have 1 over t dt, which is e to the power ln of t, because integral 1 over t dt is ln of t. Now exponential and natural log, they are inverses of each other, so they will cancel each other out, leaving you behind with t. So we have our mu of t, so which is mu of t is equal to t. Now we are going to multiply both sides of this given differential equation by this mu of t. If we do that, we get t times dy over dt plus t times y over t is equal to t times cosine of t. And if we simplify it further, we get t dy over dt plus y, because this t and t are going to cancel out. That's going to give me t times cosine of t on the right hand side and just y here. Now this left hand side is nothing but the derivative. So the derivative with respect to t of mu of t times y. So mu of t, which is just t, right? T times y. And on the right hand side, I just have the t times cosine of t. At this point, I can go ahead and integrate both sides with respect to t. So let's say I integrate the left hand side with respect to t and the right hand side with respect to t. On the left hand side, derivative and integral are going to cancel each other. That's going to leave you with ty. And on the right hand side, I have integral t cosine of t dt. Now, this we need to integrate, by the way. Oh, by the way, there is an arbitrary constant c here, of course, right? So let's go ahead and do the integral of that right here. So I'm going to do the integration of t cosine of t dt. And you can do a u substitution. Let's say u is equal to t du over dt is equal to 1, or du is equal to dt. And that gives me my dv is equal to cosine of t dt. And I can integrate both sides to get v is equal to sine of t. Now, here is one question that I get many times from students is this: how do I determine my u and v value, u and dv value? Okay, so u is t, I assumed, and dv, I assumed it to be cosine of t dt. Now, this kind of comes from experience, honestly, I have to tell you. You have to kind of play around with it or get a sense or feel for it. Let's say, for instance, in this integral, if you assumed u to be cosine of t and tried to do dv to be t dt, then you will find out that very quickly you run into a problem. So you just have to kind of do a trial and error method and sort of play around with it and get a feel for these types of integrals to kind of select your u and dv. Now let me find the integral. So according to our assumption, t cosine of t dt, integral of it is going to be integral u dv. My u is t and my dv is cosine of t dt. So that's going to be equal to uv minus integral v du. So my u is t right here, t, and my dv, v is sine of t minus integral v du. V is sine of t and du is dt. Okay, now if I simplify it further, it's going to give me t sine of t minus integral of sine of t is negative cosine of t, and finally I will get the integral to be t sine of t plus negative times negative is going to make it positive cosine of t. And I'm just going to go ahead and take this value and plug it in right here. So that's going to give me ty is equal to t sine of t plus cosine of t plus some arbitrary constant c. Now divide both sides by t, assuming that t is not 0, right? T, we are going to get on the left side t cancel out, that gives me y of t, right? Or just y. So this t and t cancel out, that gives me sine of t plus cosine of t divided by t plus c divided by t. So this should be the general solution to this differential equation. I hope that this discussion was helpful. Thank you very much.